My name is Feitosa. I'm a PhD guest here. I'm from the Center of Nuclear Energy in Agriculture for the University of São Paulo. I'm from Brazil, and I have a bachelor in biotechnology, and I'm studying the genomes from cyanobacteria, and he specialized metabolites. I started studying cyanobacteria since my bachelor. I'm using cyanobacteria from Amazon to produce biodiesel. After that, I'm going to make a professional master in a mining company in Brazil called Vale. And I studied cyanobacteria from lakes of the Amazon too. And now I'm studying this specialized metabolites from cyanobacteria of the coast of Brazil. Yeah, sampling in the field is really hard sometimes because you need to do a lot of effort, but sometimes it's dangerous too. But it's really important to see when the type of environmental you sample your bacteria, because this make much more sense when you understand how type of stress they are. Traveling for example is really nice too. Yeah, I came to vote because my advisor here, Danilo, is the one of development of the strategy that I use to assemble these genomes from cyanobacteria, and how I studied these specialized metabolites. Some part of them is from terpenoids. The most common when you found these terpenoids, and the part of this terpenoid is volatile. So here in Volt, I have a project to understand how the type of environment that I studied is a transitional environment for the marine environmental to terrestrial environmental. So this makes a lot of different stress, and I try to understand how this stress affects the nitrogen fixation from cyanobacteria, and how this stress shapes their genomes. And trying to understand how to find some of these metabolites, specialized metabolites for terpenoid, because these are volatiles. Here I do an experiment to see the nitrogen fixation, to see the light resistance, and the osmotic resistance too. And I do a lot of bioinformatics work too. Cyanobacteria, because they are a type of bacteria, they is the most ancient organism you have. Sure, they stay in the earth. They responsible to oxygenize the atmosphere from Earth, and the photosystem for doing the photosynthesis came from cyanobacteria too. So it has a long story of importance in our planet, and they are here for so long time. They can they evolved to adapt it for all type of environmental you have in the earth. So this is really important to understand how can the stress of so diverse environmentals can shape his genome, and why and how this stress can make them produce different metabolites for adaptive for this stress. Some of these metabolites like neurotoxins, antifungicide effect, so we have a lot of fat acids we can use to doing biofuels, and have some metabolites that can use to sun protection, and we have others metabolites we can use to lead with osmotic stress. Yeah, studying these cyanobacteria genomes is really important because in some places we have the blooms of cyanobacteria. So, and this happening when they grows a lot in rivers and lakes or in water reservoirs. This is a public health problem because they are toxic. Some species that produces neurotoxins, so they kill the fishes, so they causing disease for our kind too. And study these genomes to mitigate these problems and using these specialized metabolites for producing things that are good for us, like biofuels, like antifungis, like solid blocks, and they are some molecules you can use to have. They have anti-carcinogenic effect too, so it's trying to transform health problem to good things for us. To understand these metabolites and the pathway, we can block this metabolic pathway, so we can block in this cyanobacteria to produce the neurotoxins. Thank you for listening and having me here. So.